All right, today's video we're going to be talking about multiplying and dividing positive rational numbers fluently. First, let's start off with what are rational numbers? Rational numbers are any number that we can write in the form, or ratio we can write in the form of A over B. Rational numbers look like fractions, terminating decimals, repeating decimals, integers, whole numbers, mixed numbers, so on and so forth. Sometimes you're not supposed to do this, but the best way to define a rational number is to talk about what's irrational. Irrational, you cannot write it in the form of A over B. What does it look like? It looks like a decimal that goes on forever with no rhyme or reason, okay? Dot, 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 no pattern. That would be irrational. So all other numbers are rational, okay? All right. So we're going to look at our first question. This is from the 2018 test. A pharmacist puts 4.536, 4 and 536 thousandths ounces of vitamin pills into bottles. She puts 0.042, 42 thousandths ounce of vitamin pills into each bottle. How many bottles did the pharmacist use for these vitamin pills? So when we're looking at this, I'm putting things in a bottle, so I know I'm dividing. So then you have to ask, what are you dividing up? Are you dividing this number or that number? Obviously, I'm dividing this number, not just because it's larger, it's because this is what I am putting, this amount of ounces into the bottles. What am I putting in the bottles? This. So, this will be my dividend, and this will be my divisor. Now, the problem with this is, my divisor, I have a decimal. I can have a decimal in my dividend. I don't have a problem with that. What I cannot have is a decimal in my divisor, so I need to get rid of that. Well, Mr. Hewlett, how do you get rid of that? Well, that's a great question. I'm going to do 3 loopy things. And then the decimal will be right there. Well, how do you do mathematically, how do you do those loopy things where you just magically move that decimal to the very end of the number? Well, notice I moved it 3 times to the right. That means ultimately I am multiplying 0.042, 42 thousandths by 1,000. And if I did that, that would give me 42. And you've done this a lot in 5th grade, but in a fraction, whatever you do to the numerator, you do to the denominator. It works the same way in a division problem. Whatever you do to the divisor, you do to the dividend. And it doesn't matter where the decimal ends up. All I look is, I moved it 3 times in the divisor to the right. I'm going to have to move it 3 times to the right on the dividend. Again, it doesn't matter where the decimal ends up, but we're going to end up with this. And I can write a decimal at the end if I want to or not. Once I'm at that point, I can divide as normal. And so I'm going to get J once I divide it. Now, if you check your work in a calculator, you don't have to worry about moving the decimals over. You would just put 4.536 divided by 0.042 and hit enter, and you would get J. So again, it's always good to check your work with the calculator, just to make sure that you're doing it right. The calculator is always right, assuming you're putting it in the calculator correctly. So be careful with that. All right. Our next problem. A team of workers took 167.3 hours to complete a task. A smaller team of workers will complete the same task, but it will take them 1.25, 1 and 2/500 times as long as it took the first team. Based on the information, which statement is true? So let's look at what we did. We have a big team, took them that long to complete it. Now we have a small team. It took them 1.25 times as long. So times, I know I'm multiplying. So I'm going to go ahead and look at my answer choices. Look at F and G. Notice we are adding. I don't think it's going to be F or G because, again, right there it says 1.25 times. Now, obviously, you look at a smaller team. Sometimes when you do have a smaller team, it will take you longer. You don't have as many hands, not as many people, so it can take longer. So I'm going to multiply 167.3 times 1.25. Now, if you look at H and J, it's set up where you are multiplying 167.3 times 1.25. All right. So which one is it? Well, let's see, where do I have room? I'm right up on top here. I'm right 167.3 times 1.25. Now, the important thing about multiplication is you do not have to line up the decimals or place value. You have to do that when adding or subtracting. But multiplication, just write the multiplication like a normal problem. And when you multiply, technically, you forget the decimals are there. So down below where I have some room, if I were to multiply 160, let's go ahead and multiply 1,673 times 125. I'm going to get 209,125. And I'm not going to put a comma there because my next step on a multiplication with decimal problems, I'm going to figure out on the top number and the bottom number, how many numbers to the right of the decimal do I have? Well, I have one here, 2, and 3. So I have 3 numbers total to the right of the decimal. Well, why is that important? Because that's going to tell me that I'm going to need to move my decimal 3 times to the left here. Because honestly, forget about the decimals, 1 times 167 is 167. 2 times 167 is 334. My answer needs to be in between there, so if I didn't, that way I can kind of check to see if I moved my decimal in the right place. So my answer is going to be 209 and 125 thousandths. So obviously, J is our answer. All right, next question. A baby weighed 7 and 25 hundredths pounds, and the LB, be careful when writing the LB because it looks like a 1, but that stands for pounds, at birth. At the end of 8 months, the baby weighed 2.5 times its birth weight. So 2.5 times, that means I'm going to be multiplying. How many pounds did the baby weigh at the end of 8 months? Okay, so we can do this 2 ways. I can multiply it out. And again, I kind of lined them up. I didn't mean to. And if I were to multiply these out, I'm going to get, I'm going to cheat, go ahead and get my product. But then I have to ask again, how many numbers to the right of the decimal do I have? 1, 2, and 3. 1, 2, and 3. So my answer is H. Well, if you look at the decimals, these are somewhat pretty decimals. I could multiply it as a fraction. Ultimately, I would get the same thing. And if I were to divide 145 by 8, I would get 18. And 1 is a remainder. And know this number and these numbers are equivalent. 18 and 1/8 and 18.125, 125 thousandths, are equivalent. So just realize fractions are cool. So if you like using decimals, you like to use them with fractions, preferably, you know how to do it with both. All right. A recipe for cookies requires 2/3 cup of butter and wants to make 3/4 of the recipe. That means she wants to make less than what's called for. How many cups of butter should Rama use to make the cookies? Now, looking at this problem, I already know that she's not using the whole recipe. She's not using more. She doesn't want to make more than the recipe calls for. She wants to make less. So I know my answer is going to be less than 2/3. So starting off, I can go ahead and cross off F and G. That means it's going to be H or J, so let's figure out which one. So let's write down what is given. If I use 2 cups of butter, that would give me 1 recipe of cookies. But what if I were making 3/4 of the recipe? How many cups of butter would I use? Well, I don't know how many cups of butter I need, but I do know that I'm going to use 3/4 of the recipe. That's all I'm going to make. Now this should look like something you've done in the past. When you set up equivalent fractions, sometimes you can go, how do you go from the top to the top, numerator to numerator, denominator to denominator? But in 6th, 7th, and 8th grade middle school math, we work a lot on setting up ratios and proportions and solving them. So on this, the one way that will work for all of them is to cross multiply. So again, I'm going to go how I set it up. On the top, I have 2/3 cups of butter. We'll make 1 recipe. On the bottom, I don't know how many cups of butter I need, but I do know it's going to make 3/4 of the recipe. Now for cookies. Now again, notice I have recipe of cookies on the right, recipe of cookies on the right, cups of butter on the left, and that would be cups of butter too. So if I don't know how to solve it, the easiest way is to cross multiply. 1 times x is x. You can write a 1 in front of it, doesn't really matter, but it's just 1x. If I just wrote x, how many x's would I have? That's right, 1. How about I leave the 1 there? Then I'm going to multiply 2/3 times 3/4. And 2/3 times 3/4, 2 times 3 is, that's right, 6. And then 3 times 4 is 12. Well, I don't see that answer over there. Because when I have x alone, that means that's what my answer should be. So let's see if we simplify 6/12. If we get the answer, we'll go into 6 and 12. That's right, 6. We simplify it. And that is our answer, because the answer is J. So again, you need one, if you want to make one batch of cookies, you need 2/3 cup of butter. If I'm only going to make 3/4, because if you didn't have as many people coming over, you didn't want to eat that much. How many cups of butter would you need? You need 1/2 cup. Okay, so we set up the proportion and solved it by cross multiplying. All right. A grocery store sells steak for $6.10 per pound. What would be the cost of 2 3/5 pounds of steak? Now, notice this is a decimal. We have a fraction. All our answers are in decimal, so I think the easiest way for this problem would be to turn the 2 3/5 into a decimal. Well, how do I do that? Well, let's forget about the whole number for a second, and let's think about 3/5. There's multiple ways we could do it. We can turn that into 10. How do I go from 5 to 10 times 2? Whatever you do to the denominator, you do to the numerator, so that's 6/10. And 6/10 is 6/10. Or I could divide the numerator by the denominator and get, that's right, 6/10. Regardless of which way you do it, you should get 2.6. So I'm going to erase all this. And then all I'm going to do is multiply. I can put the 0 at the end, but I don't need it, so I'm going to leave that off. And then 2.6. Again, the decimals lined up, but you don't have to do that with multiplying. Again, multiply the numbers. You would multiply 61 times 26. You would get 1,586. Well, is that my answer? I see something that looks kind of like it, but it's not the same thing. So what do? Well, once you're done multiplying, then you account for the decimals. So how many numbers to the right of the decimal do I have? I have 1 here and 1 here. So what do I do then? I start at the right, and I'm going to move my decimal 2 places to the left. Why 2 places? Because again, I had 2 numbers to the right of the decimal. Okay? And so that ultimately is going to give me $15.86. So my answer is C. All right. Well, this concludes this video on multiplying and dividing positive rational numbers fluently. So hopefully this has helped. But if you have any other questions or concerns, you can email me at jhewlett@leisd.ws. Thanks, and I hope you have a great day.